5.3 Logarithmic functions and their graphs. In this section, we are going to learn how to evaluate logarithms. In this section, we are going to learn how to evaluate logarithms, how to evaluate the common logarithms, natural logarithms, and graphed logarithmic functions. Evaluate logarithm. Logarithm is an inverse function of the exponential function. So when you have the exponential form, for example, 2 to the power 2, we know it's 4. Rewrite this exponential equation into the logarithm form. This is exponential. When I rewrite this form into the logarithm form, you write down the log. Now the base 2, so the base 2 go underneath the log. The result is 4. You put the result a little bit higher than the base. Is equal to degree power 2. So your degree is turned to a single number on the other side. So when I convert the exponential form into the logarithm form, the difference is you have a log along into it. Base 2 go underneath the log. The result 4 right next to the base, and the degree power by itself to the other side. We do one more practice. 2 to the power negative 1, this is a half. Exponential form. Convert the exponential form into logarithm form. You write down the log. Base number is 2. The result is half equal to degree power negative 1. We look at the logarithmic function. If b is a positive number greater than 0 and b not equal 1, the logarithmic function with base b is defined by y equal log base b of x. If and only if when x equal b to the power y. So this is the exponential function. Your x equal b to the power y. When I convert exponential form into the logarithm form, the degree power by itself, right, on one side, and then you add on the log into it, base b go underneath the log, and the x is a result right next to the base. So that's the way you rewrite it. Or if you switch the order from here, b power y equal x, probably this is the easy way for you to see it. Exponential form. Now convert into a logarithm form. You have the log, base b, the result is x equal to degree power y. So it's the same structure. The domain of the logarithmic function is the interval from 0. It's open 0, which means not include a point of 0. Open 0, comma, infinity, close. The range is the interval for all real number, from negative infinity to the positive infinity. Again, logarithm function is the inverse of the exponential function. So the exponential function we have from 5.1, we have learned the tendency of the exponential function is a going up function. When your b is greater than 0, it passes into 0, 1, it passes into 1, b. This is exponential function b to the power x. The inverse of the exponential function is a logarithm function. In the logarithm function, you will have the curve always stay on the right hand side or stay on the positive x-axis. And here is the asymptote. it never really touch the y-axis here, right? Just keep going down and keep going up forever. So the domain of your exponential function is all real number, which is negative infinity to positive infinity. The range of your exponential function is 0, go to positive infinity. And it has a horizontal asymptote here. Logarithm function, this is a logarithm function, this is exponential function. Logarithm function, it has a vertical asymptote. Let me use another color. All right, so inverse, right? So with exponential function, it has the horizontal axis. When it comes to the logarithm function, the horizontal asymptote turns to the vertical asymptote. The domain of your logarithm function is the range of the exponential function. So the domain is from 0 go to infinity. It never across the vertical asymptote unless it translated. The range of your logarithm function is the domain of the exponential function. So the range of the logarithm has negative infinity up to positive infinity. Find the y in each equations. So this is a logarithm form. We need to find the y. So the way we finding the y, we need to rewrite the logarithm form back to the exponential form. So we do the practice here. The base number is 2. I know this is degree power, right? So you have 2 to the power y is equal to result a. A is equivalent to the degree power 3. So according to the theorem, the property of the exponential function, when you have the b to the power x equal b to the power y, we can simply to cross out the base and let the x equal y. We have the same structure here. 2 to the power y equal 2 to the power 3. So I can just simply to cross out 2 and let the y equal 3. Example B, log base 5 of 1 equal y. Same way, we rewrite into the exponential form. 5 to the power y equal 1. 1 is equivalent any number has any base number with a degree power 0. So now we can cross out the base that the y equals 0. Log base 7 of 1 over 49 equal y. So I rewrite back to the exponential form. 7 to the degree power y equal 1 over 49. 1 over 49 is the same way of 1 over 7 power 2. 1 over 7 power 2 is equivalent 7 to the degree power negative 2. So now we have 7 power y equals 7 power negative 2. That means y equal negative 2. Quick practice here. 1 over a is equal a to the power negative 1. 1 over a squared is equal a to the power negative 2. And it just continue to build up the structure. 1 over a to the power 5 is equivalent a to the degree power negative 5. All right. Evaluate the common logarithm. Many applications use the base number 10 logarithm. We call that it's a common logarithm. In other words, when you see only the log x, there's no base number here. That means it has a common base 10. So if you don't see the base, that means it's 10. Now we look at the table here. Log base 10, 1 over 100 is equal negative 2 because when I convert this logarithm form back to the exponential form, I rewrite it into the 10 to the power negative 2. And 10 to the power negative 2 is equal 1 over 100. So 10 log base 10 of 1 over 10 equal -1 because 10 to the power -1 is equal 1 over 10. In general form, you can treat if you don't see the base number there, you can just fill in the 10. So you have log base 10 of the 10 to the power x equal x because this 10 cancels out with the base 10. Finding the x in the equation log x equal 0.7482 to full decimal. Solving this problem, you need to use a calculator. So let me write down here. Log x equal this number, right? So we know it's a base 10. Now convert the logarithm form into the exponential form. You will have the 10 to the power 0.7482 equal x. Now you just type in this number into your calculator. Then you will find the x. So the x is approximately 5.6002. The question asks you to run to full decimal place.